Today we was going to talk about some really IoT protocol, and that is CoAP and MQTT. So as we mentioned, there's MQTT kinds of facilitate machine-to-machine communications, and it's used the publisher subscriber, just like the DDS you mentioned earlier. And the other is the CoAP, which is Constraint Application Protocol. And the CoAP facilitates an end device as a server or provide some kinds of service. So we can call it a CoAP server for the end devices. So let's talk about MQTT, machine-to-machine protocol first. So the MQTT actually was developed by IBM and Eurotech in 1999. And Dr. Andy Stanford Clark of IBM, and this is the Andy, and Ari Nippo of the Alcom, and they changed name to Eurotech. This is the Arlens. And the purpose is kind of we want to try to discovering producers mean some kinds of publisher, and discovering producer and consumer for machine-to-machine communication. So producer is something like publisher, consumer is something like a subscriber. So for the MQTT, actually they show a lot of application actually need to use MQTT. So for example, in transportation and logistics, you have bunch of trucks driving all over the United States. And you need to know where it is, and do you really deliver the goods to your customer or whatever. Or maybe in the transportation, you have a high-speed railroad, or maybe helicopter, different kinds of things you need to maybe send some information back to your control center, something like that. Or it could be used in healthcare, and maybe in the smart grid, okay. And maybe for the civilians, okay. So a lot of application, the machine need to talk to another machines, okay. So for example, in civilians, you have some kind of devices, hooked on the foot of the prisoner, right? And the devices will talk to, a short distance devices, and the devices will talk back to maybe the law enforcement department. And well, in the beginning, I guess you have to pay for this standard. So only a few people in IBM or in Eurotech actually use it. And later in 2008, they provide an MQTT-S. S means sensor network. Because at that time, UC Berkeley actually came up with, sensor network. And sensor network is really cheap, and you can deploy a large of devices. You just throw maybe to the mountain or to detect maybe, in the enemies, if there are any enemies, come to this area or not. So it's cheap, and you can use for, send the device will talk to the device, and eventually they will send to the satellites and go back to maybe American or control center, something like that. And during the 2010s, they know that for the IoT, maybe billions of devices will be connected together. And if you need to pay something for that, people would not use it anyhow. So they decide to make it royalty free. So right now, after 2010, a lot of people, really try to use it and think this is very good, technology for IoT applications. So in 2011, they donate all the MQTT source code to an IoT standard organization called Eclipse Foundations. So Eclipse Foundation, there is a working group called machine-to-machine working group. They donate all the source code to them. And in 2013, and then they revised the sensor network spec, because S is not kind of very difficult to understand. So they changed to SN instead of S, and they came out with the third version 1.2 spec for the sensor network. And also on 2014 October, MQTT have 3.1.1 release, and also they donate to the OSIS standard and become what we have today. Right now it's still even in 2018 it's still 3.1.1. So this is the standard we are using at the moment. So you can see that if you want to try it out, and you can use Eclipse Foundation. They have a implementation called PAHO. So they have C version, C++ version, and also Java versions. And they have also Lua version, so you can try it out if you understand any of this language. So this is the IoT protocol. So as we can see that MQTT is in Brunei. So you can see that before 2010s, almost no one is going to use the MQTT, and there is someone using it because there is news say that MQTT will become royalty free. So some party chose it. As you can see that after that, then people like to use MQTT for machine talk to machine, something like that. And during I guess it should be around 2008, and or maybe 2006, and they CoAP actually have become the dominant IoT standards. So you can see that in the beginning, CoAP will be used to almost people use CoAP as the IoT standard, but you can see that it's still keeping quite stable. They are not jumping very high, and well, there are some other protocol, more advanced MQTT protocol called AMQP, and like DDS. DDS is especially for industry IoT. So I guess MQTT and CoAP are good for both industry IoT application and consumer-oriented applications. However, if you talk about real times, probably none of these protocol can support the real-time features. That's why DDS is a little bit hype at the moment. But you can see that it's difficult for you to either to understand and write a program is kind of difficult compared to MQTT. So what's MQTT? MQTT stands for a lightweight message queuing, telemetry, and transport protocol. What does that mean is they use PUB/SUB model, publisher and subscriber, and they introduce an so-called MQTT broker to kind of become a broker for publisher and subscriber. So you can think MQTT broker is a kind of server.
It's like the domain in DDS.
Yes, your domain actually it looks like a domain, and inside the domain you can create a lot of topics. So you might have another MQTT broker, and you have another domain, and you can have a lot of protocol.
On MQTT, you use IP address.
Yes,
Okay.
yes, yeah. They use IP address.
Like on DDS.
No, you need to know where is the broker. You have to connect to the broker first. Yeah.
Okay.
And there is no like registered server. You ask, where is the MQTT broker, and then you communicate with the MQTT broker. There is no such. But you can, do something like this.
Okay.
So at the moment, you have to, every either publisher or subscriber, you need to connect to the MQTT broker before these two guys want to send information. And because it's very simple, so the code actually is really compact. So you can implement in very like a constraint devices, like in this guy. This have only 64K RAM, and they still can run it without any problem. And also the package size is really compact. For example, in a package in HTTP, it could add up to maybe 200 bytes per package. However, in the MQTT, it could be only 4 bytes. The same amount of information, it can add up only 4 bytes. So it reduces a lot of the package size, and also they provide some kinds of quality of service. Okay. And all the information actually are stored in the broker. So there is a message queue. Message queue is a queuing, store message. And as we mentioned that there is no priority. In DDS, they support priority. So that means some message actually is more important than others message. However, for the message queue, just first come, first serve. There's no priority in MQTT. So the message queue actually is associated with the topic. When you create a topic, and then you have a queue to store all the information. So you can see that MQTT actually is in ISO model is layer 5 through 7, and underneath it is used only TCP. And for the CoAP, they use UDP, something like DDS, as you mentioned. And then use TCP transport layer security protocol. Okay. So MQTT actually belongs to the application layer. Okay. And then based on TCP and IP. So what kinds of application they can be used in MQTT? Okay, so sorry. This page, I forgot to change in English. So for the first one is mobile to mobile. So like right now we have a 9 group, right? So 9 is something like a broker. And so if I send a message to the group we have, then they will broadcast the information to you. So you can either, also in Windows, you can have a 9 application. So they can send to your phone or your PC. So that is mobile to mobile communications. Like a Facebook Messenger, like a global messenger, or 9 we are using, or in mainland China, they use WeChat. Okay. So I'm not sure it's popular in French or not. In Asia, people don't use, they communicate by use these kinds of.
Well, we use Facebook Messenger.
Oh, okay.
In China,
Yeah. Use Messenger.
They used to speak to their phone and send it by WeChat in China.
Oh, great. Yeah. You can do something like that. In the 9, actually, you can also send the message to your machine. So you can like turn on or turn off your home appliance by using 9.
Okay.
Yeah. And the second application is the wireless sensor network. As we mentioned that during the 2004 or 5, UC Berkeley invent a device called MOTE, M-O-T-E, and they provide a tiny OS inside the MOTE and with different kinds of sensor. So the sensor can talk to the sensor directly. So wireless sensor network could be used, to monitoring the debris flow of IoT. Okay, so we just did this one. Just debris flow. In Japan or in Taiwan, we have a lot of typhoon, right? And when the typhoon come, they come with a lot of rain. And when the rain, heavy rain in the mountain, it become debris flow with the rock, water, and then flow from the mountain. I'm not sure in your country, do they have these kinds of problem? Typhoon? No much typhoon, right? But for this Asia, in the Asia country like mainland China, they all have these kinds of problems. Heavy rain, and then the water with rock, flow into the village. And the last one is Internet of Things, right? So actually, we have one example here. So this is demand and response model. So this is power generator, but how do you know how many power you need to generate at this moment? Okay, so the way is you kind of measure the current usage, and then because when you say power, the power generator actually they don't have the capacity to store the electricity you generate. You have to use right away. So that's why, demand and response is really important. Usually in Taiwan, you can see that this is the summer because it's so hot, so everybody, use the air conditioner, something like that. So you can see that we need a lot of electricity. However, when you say a power generator, if the power is not good enough, and then they will break everything down. Okay, so actually the power generator is something like this. They always have much more power generated than the real usage. So I guess this always wasted because you are not able to store the energy anyhow.
In France, we use more energy in winter than in summer.
Okay, yes, it's too cold, so you have,
you use the heater.
Yeah, no. I mean, the winter here probably is very, you will come and feel very comfortable. Yeah. But I mean, it's too cold for us. Even right now, you can see that t-shirt. Yeah. Jacket. Okay. So actually, MQTT actually facilitate, as I mentioned, M2M communication. And how machines talk to each other. When we are young, we might use, I'm not sure, in your country, do you play something like this? You put a string and with a cup, and then you talk to each other, right? It's when we are kids, we do something like this. So in real world, and a machine need to talk to another machine, they have to go through, a broker. Because not just one device needs this information. You may have many publishers and many subscribers. So the way to do it is you always send some information to the broker, and then you don't worry about that. The broker will have the responsibility to send this message to all your subscribers. So just send, and then you don't have to worry anything at all after that. Okay. So I guess if you look into the architecture, and there are two roles. One role is called client, the other role is called broker. And the client is something like publisher, can be subscriber, or both. Okay. So the client can register topic in a broker. The broker is actually a server. They have much more storage and much more power, computation power to do the computation and store the information for you. Okay. So the publisher actually very easy. They just publish message and to the topic in the broker. Okay, and the subscriber will subscribe the topic and then receive the message. Okay, so it's kind of very simple stuff. For example, in here we have this publisher send a message to this topic and this topic, and you can say publisher can send multiple message to different topic, right? And this topic actually, this publisher send information to this guy, and this publisher also send to the same topic. And you can see that this is many to many, right? We have a subscriber here and have another subscriber there. So the broker, as you can see, is equivalent to the domains in your DTS. And actually, they have some kinds of fault tolerance. For example, you might have two brokers. If one broker, is crashed, then the other broker will take responsibility to send the message to others. So the broker actually are servers for these clients, and they can store message in the message queue. And the message queue is something like when you create a topic, and whenever you receive the message, they will store in the message queue first, so that you can guarantee that all the message, if sometimes the subscriber might not have the network connection. For example, you drive to a tunnel, then you probably lost the connectivity, temporarily. But you don't have to worry about that, because the broker would do his best to send the message to you. After you come out with the tunnel, then you connect back to the network, and then you will receive the message.
It's a TCP connection, like they have got enough knowledge and to be sure that.
But TCP only try a couple of times, and then if you fail, they just say, okay, I'm not able to do this for you.
Yeah.
But when you have these kinds of quality of service, you can say, okay, wait maybe a year or maybe a month.
Yeah.
So
to try again.
To try again. So I guess it's more reliable compared to TCP's best effort. So this is MQTT framework. Okay, we have we wrote some kinds of application, like we have temperature sensor. We try to send information to others. We kinds of publisher, and we could be a subscriber. We can read something from others. Okay, so this is MQTT client. MQTT client can be either publisher or subscriber or both. And underneath, we use TCP/IP and go through the TCP/IP or maybe internet. And for the server, we have used also TCP/IP. And here we call a section. It's kinds of dialogue. As I mentioned that the MQTT actually always connect to the internet. So they will send kinds of heartbeats to the broker. So how do broker know that you are alive? That means the MQTT client have to keep sending heartbeats to the MQTT server. Just like TCP, you need to send heartbeat, something like this. So they have some kinds of heartbeat message, and you can actually set how long you want to send the message to the server. And if the server, maybe 1.5 times of your keep alive time, then we'll just disconnect you to the server. So you have to use, like you say, three-way handshaking, connect back to the MQTT server. So after you have three-way handshaking, then you have to keep sending your heartbeats to the broker. So the broker have a bunch of, like you see here, broker have a lot of topic, created by the clients. So that by using the topic, clients can send information to the topic, and the topic will forward to other clients for the subscribers. And for the topic, actually is just similar to the directory names. Okay, so for example, I can say this is like English style, right? My home and my ground floor has been the first floor. Okay, and the living room of my ground floor, and the temperature sensor. So I can use this way to identify one sensor, or I can use wildcard here. So for example, I want to say that my home and in my ground floor, and maybe not just living room, I have also restroom, and maybe I have a bedroom, and maybe I have a kitchen, and all the temperature sensor I want to register at once. Okay. And also I can say something like this, my home, my ground floor, and I use a hash sign here to indicate all the sensors attached to the first floor, something like that. So they have different kind. You can identify just one topic, or this will be multiple topic, and this another multiple topics. And you cannot say, okay, I put a plus sign here and another plus sign here there. No, only one. Okay, so this is some kinds of restriction. So this is some kinds of example. So as we mentioned, the topic name actually is similar to the path for file systems. So you can say wireless sensor network, and this is have temperature. Room 1 has temperature and pressure sensor. Room 2 have another temperature and pressure sensor. And you can say all the temperature mean this temperature and that temperature. And you say R1 plus, what does that mean is, all the temperature. And you put a hash sign here, that means, all these sensors. Okay. So I guess they are kind of flexible when you say subscribe something, not just one by one. You can subscribe, a lot of topics at the same time. So you need to have broker. Okay, so they are free broker. Okay, so sorry, this is a broker. Okay, so I should put an O here. Okay, broker, and they are commercial broker. For example, the most powerful broker is IBM Message Site. This is IBM Message Site, and their capability is to connect millions of clients, MQTT clients at the same time. And when these millions of connection, they can process millions of messages per second. So this kinds of hardware solution for MQTT broker, they dedicate for MQTT broker. And they are also software solution like HiveMQ. HiveMQ, just normal server, but they can facilitate 10,000 connection at the same time. And for the broker, actually, there's one broker called Mosquitto, and they have this is open source. You can download it. And also you can download the binary as well for testing. Okay, so you can have your own MQTT brokers. However, this version can support up to 10,000 connection. But I mean, a 10,000 connection is good enough for us. Okay, and also you can use Apache Software Foundation's ActiveMQ, and I don't know how many connection you can because I haven't tried it, but I guess it's much larger than this one. Okay, and maybe less than this one, something like that. Okay, and this Eclipse Foundation actually you can use all the times. So today we are going maybe today or tomorrow. So I guess 46. Maybe we don't have time for. Maybe we can do a very simple one today. So the IoT-Eclipse.org actually is free for everybody, and they open 24/7 and 365 a year. So you can always use this broker. So you don't need to set up any broker. You just connect to this domain name, and then you can test your end devices. So maybe we can try mobile to mobile first. So maybe Henry and Jonathan, you can try create a topic, and Henry can send message to Jonathan, and Jonathan can send message to Henry. Okay. So first, if you are in Android, right?
Yes.
So Android, you have to download. You just search, go to the store. Google Play, and search for MQTT, and then download this one, the IoT MQTT dashboard. Like something like the cloud and with MQTT. And for the your iPhone, right?
Yes.
So you have to seek MQTT 3T.
Yeah.
Okay, and download it.
This one.
Oh yes, this one, right? And you try to download it, and then we can So maybe when you are downloading, I will keep going, right? Yeah, you have to connect to the IoT. So okay, then we need to, after you download the application, you need to connect to the IoT.eclipse.org, as I mentioned, and let's see how to do it. So after you download the MQTT client, and there are two things to do. Maybe tomorrow, your machine can talk to this machine. For example, you can turn on the light or turn off the light, something like that. Okay. And today we are going to say Jonathan send a message to Henry, and Henry send a message to you. And tomorrow, we will try your handset to the device, and also the device to device as well. Okay, that's what we do tomorrow. So the first step is you need to connect to the MQTT broker. So the first thing is for Jonathan. Did you successful install?
Yeah.
Okay, so you click this button, add. Okay, so when you click the add button, then they will come out with this figure, right?
Yeah.
And then for this figure, you type your client ID. So I guess the ID have to be unique. So for example, if you call Henry, and if Jonathan say I'm Henry, then Jonathan's Henry will be replace you, something like that. So because we don't create a username and password. You can use the username and password, but for the Eclipse.org, they are free for everybody, so you can choose your own name.
But doesn't it create a security issue, because anyone can have access to the information you send?
Yes, in this case, you need to have your own broker, and then everybody have to register as a user, and then you have to type your username and password. But at the moment, we don't. You just type maybe just Henry and this IoT.eclipse.org for put in the server side, and the TCP port will be 1883.
Is it always 1883 or?
Yes, for the unsecure protocol is always 1883. But for suppose you want to use transport layer security, then it will change to 8883.
All right.
Okay. So did you say it's successful?
Yes.
Okay. Great. Okay. So I guess and then you add the create button. Then if you connect to the IoT, then they will say IoT. You connect to. May I see your phone? Did you connect? So right now it's haven't connected. So you type this one, and then you say already connect to the Eclipse, right?
Yes.
So right now you are both fine. Okay. So the first step is connect to the IoT.eclipse.org, and I guess, and the next thing is you subscribe. You have to create a topic, and Henry have to create a topic. Maybe Henry create a topic called Henry, and Jonathan create a topic called Jonathan's, so that you will talk to each other through these two different topics. So first go to the subscribe, and then you click the add button. So go to the subscribe and click the add button. And for the add button, this family name is just for use on your own use. However, the topic actually will be registered in IoT.eclipse.org. So it's kind of, I want to subscribe this message queue, the information, any information submit to this one, I will receive. So right now you have to tell what topic. So okay, so after you subscribe this one, right, and then Jonathan will send a message to Henry, and and Henry will send a message to Jonathan. So the way to do it is you go to the publisher. You go to the publisher, okay? You want to publish, right? And then you choose text. They have different kinds of GUI you have to do. You can send, and you choose text. And then you key in, friendly name is, for your own use. But you have to say Jonathan's topic. So you say Jonathan's topic. And then, create. So you type, hello to Jonathan. And then click publish. So you go back to your
il y a une majuscule.
So did
I
you
didn't put the majuscule after the Jonathan.
This is the subscribe message. And do you subscribe? And you have to subscribe. You have to subscribe Jonathan first. So okay, you try that. So you have to type John with pick the character later.
Yeah.
So John again. No.
Jonathan, le perturbateur. Origin text. Ah mais attends, c'est ce que tu as fait les mêmes choses. Regarde, je vois ce que...
Okay, yeah, I guess you have this one. Oh yeah, yes. Okay. Yeah. So you can try to, send a message to Henry. Actually, Henry sent a message to IoT-Eclipse.org in England, London.
Yes.
And then the message actually go to Taiwan and send to your phone. Okay. So it's kind of, go back to England and come here, something like that. Okay, so we finished our first, MQTT lab today. And maybe later you can send a message to Henry and see if it's working or not.
Je suis sur ça, parce que t'es sur ce sujet-là. Je vais t'envoyer là, tu publies sur ton sujet, toi. Là, t'es à Jonathan. Oui, j'ai publié.
You have to say, I want to publish to...
Yeah, you got it.
Okay, great, yeah. Okay. So we can put some summaries. PubSub model, you see, is pretty easy, right? And not like DDS. A lot of work to do, but you need to learn something else. So before everything work fine. So you can see, MQTT actually is a PubSub model. Publisher and subscriber. In the middle, we do have a server called broker. Okay, so tomorrow we will do the IoT end device as devices as the publisher or subscriber. Okay, and then we will send message. First is your phone can send a message to your devices first. And the second is your device of Jonathan. Jonathan will send a message to your device. For example, I can say it's too dark, and your device should say, "Okay, I should turn on the light," something like that. But they are not the same device as we did, last week, something like that. Okay, so you can see that the message transmission actually is asynchronous. What does that mean is the publisher send a message to the broker asynchronously. You don't have to wait. Okay. After you send the information, then these subscriber will receive the message one by one. And if they receive all the information, then the MQTT broker would delete this message after everybody got it. Okay. So the publisher send a message to the topic, and the broker will store the message in the message queue. So when you create a topic, actually you create a message queue.
For the MQTT broker, like if it receives lots of message and it doesn't delete them because it didn't send it to everyone, like can't someone do a DDoS attack like this, like sending plenty of message just to break the MQTT broker?
It could, but I mean when you say broker, it's a lot of memory.
Okay.
But I guess it's highly unlikely you would use up all the memory.
All right.
So because when you say broker, you might have 16 gigabytes memory. They can also use the hard disk as cache. Oh. So unlikely you can feed up all this.
You can try DDoS, but it's
you can try. You can keep sending. Okay, but they must have. You understand? You have that. It doesn't like the DDS. Even they don't have subscriber, you still can send message to it. Why is that? Is because I can say this is return message, or return message is something like maybe Jonathan haven't connected to the internet, but you want when Jonathan connect to the internet, they have to get some message. That may be in DDS, but I don't know.
In DDS, you can send message, but they won't be delivered to anyone because it's multicasting. So if no one is subscribing to the multicasting group, like the domain is like a multicasting group, and if no one subscribes to the multicasting group,
but what happens if I have one application, as I mentioned, that when someone subscribe your message, you're going to say hello, welcome to my
you don't think like DDS can be like compared as the new IPv6. Now you don't have any broadcast on IPv6, but you got a multicasting, and so you just join a group of when you're a subscriber. The domain is a group of multicasting, and the publisher just multicast to all the people that have joined the group. And if there's no one, he doesn't multicast to no one. If it's an end devices, he sends you the IP address. But you don't use the IP address because like the kind of DNS server, the info repo, store all the information.
So for example, if I join the group,
the domain,
but maybe I was, as I mentioned, when I went through the tunnel, and I temporarily, cannot receive anything.
I don't think so because it's real time information. It's like if you were watching a live stream. If you just miss the information, you just don't.
Okay, but in our MQTT, when you pass through the tunnel, you get everything. For example, you have message like 9, right? You won't want to have some information that's lost and you don't know.
Yeah, I don't know because I know you still got an acknowledge to say the message has been delivered. So in the program, if for the publisher program, you can resend the message until you have an acknowledge.
But I mean, and then it's to, I guess they will break out, if it block out a lot of stuff. You will do something like this.
Yeah,
you always need to have acknowledge, then, and I don't know, it's synchronously or asynchronously.
I think it's asynchronous. It depends. I think the LDL is synchronous, and
so if it's synchronous, then you cannot do anything at all, right?
And and the DCPS is asynchronous.
Okay, maybe I think if you think many application is similar to the MQTT, like a messenger, right? Messenger is a kind of a PubSub model.
Like the acknowledge isn't an obligation, so you can send message and don't care if they haven't been acknowledged. It's like for a time, And if there's no one who received the message, if you have no acknowledge, you can like configure and say, I didn't receive acknowledge, so I'll send it back in 2 minutes. But you have to configure it yourself. This is the interesting part. In DDS, you can configure everything.
Okay. So maybe you read through it, and probably in some cases you can do something like MQTT.
Yes, you just have to program your publisher and say, if no one acknowledge my message, I'll send it back in 2 seconds or whatnot. You have to do it yourself.
Keep sending, but I mean the data are not real time at all.
But you send the new data, like you say, no, it's not real time anyway. Like if the temperature haven't been, I have to send the temperature of I don't know my oven, and so I send it. No one receive. Okay, I will wait like 3 seconds. I'll send it the new temperature until someone receives.
Yeah,
you have to program it. If you want to create an acknowledger thing, you have to program it yourself.
But I mean, you have a lot of work for writing a publish or something like that.
Yeah,
you can see that you don't need to do this in the MQTT.
Yeah, everything is
they always has a broker to taking care of those stuff for you.
Yes.
So that's the beauty of the MQTT. Okay.
Yeah.
So maybe we will keep doing the MQTT tomorrow. Okay. Maybe also at 10. Okay. Yeah. We'll see you tomorrow.